Let us discuss Merceau algorithm. This algorithm use divide and conquer algorithm development strategy. Here you can see the main program. Here we have 5 elements in the array. The lower index is 1, the left index is 1, the right index or the higher index it is h. Then inside the main program we are calling the Merceau algorithm. This is the body of this Merceau algorithm. It has two calls of this Merceau. This is a recursive algorithm. Then merge. The merge algorithm will merge two sorted arrays. Complexity of this merge will be big O n. We will see it later. Okay. Inside the merge sort, it will check whether the left index is less than the right index. It will calculate the middle index. Then it will partition the array into two. Lower index to mid, it is one array, and mid plus 1 to the higher index, another portion of the array. Then you can see here this first function call, it will process at most n by 2 elements. So this is the function call, and the second function call, again it will process n by 2 elements at most. We can say the first call, it receives n elements, then it will divide the array into two, n by 2 elements and n by 2 elements each. We can represent it, the process, the division process, like this. The first function called from the main, it will receive n elements, and this array will be divided into two, n by 2 elements each, and this will proceed again n by 4, this also n by 4, n by 4. So this is this circle, it represents a function call. Here the problem size is n. In this function call, the problem size is n by 2. In this function call, the problem size is n by 2. Okay, finally it will reach a function call with one element. Okay, that is the end of this recursion. See, L equal to h. The end of this recursion is when L is equal to h. L equal to h means we have only one element to be processed. So no more division there. These functions will start to return. A very root note, as to divide the array, then merge the elements returned by these two function calls. Here, a very function call is represented by a circle. Inside a function call, it has to divide the array into two. Then it has to merge the elements and arrange them in some ascending or descending order. Inside this, the merge is the main work, and we will see the complexity of this merge is big O n, so its cost will be Cn. Since merging is the main work inside a function call, we will see the cost of this function call is Cn. Here we represent all the function calls as a tree. The tree will end when the problem size is 1. See, in the first call the problem size is n, and this array has been divided into 2. So n by 2, n by 2. Then each array of size n by 2 will be divided into n by 4, n by 4, and each n by 4 will be divided into n by 8, n by 8. Like that it goes. Then finally the recursion will end when the problem size or the number of elements to be processed is 1. Let us analyze this merge sort using iteration method. Let Tn equal to the time to process n elements or the cost of processing n elements, and it is equal to processing 2 problems. Let us consider this level only. Then we can see it is the time to process 2 problems, each of size n by 2. So this is equal to 2 problems, each of size n by 2. Tn by 2 is the time to process or time or cost to process n by 2 elements. Then we are speaking about this function called. So once these functions are returning, it has to merge. In addition to that, it has to calculate the middle index, etc. The main work is merge. We will consider the cost of merging, that is the biggest one. So we will add that to this total cost. Then we will get Tn, that is cost of processing n elements, equal to time to process 2 problems of size n by 2 each, that is 2 into n by 2, plus the work done in row node. Okay, we are considering this function called. Then let us think about what is Tn by 2. Time to process n by 2 elements. From this picture, it is very clear that each problem of size n by 2 is divided into 2 problems of size n by 4 each. So Tn by 2, the cost of processing Tn by 2 is equal to Tn by 4 plus, it has to merge n by 2 elements. Okay, so C n by 2. Okay, we will replace Tn by 2 with this equation. So we will be getting T of n equal to 2 into 2 Tn by 4 plus Cn by 2 plus our old Cn, that is Cn. Okay, so it is equal to 4 Tn by 4. See, this 4 into Tn by 4. Here we have 4 problems, each of size n by 4. This is represented by 4 into Tn by 4 plus 2 into Cn by 2, it is Cn plus Cn, and this is equal to 4 Tn by 4 plus 2 Cn. If we call this equation 1, this will be our equation 2. Then we try to expand this n by 4, so it will be 4 into 2Tn by 8 plus Cn by 4 plus 2Cn. Okay, this 2n is coming from here. Okay, 2Cn. This is equal to 8Tn by 8 plus 4 into Cn by 4, it is Cn plus 2Cn, so 3Cn. This will be the third equation. Okay. So let us generalize this for some kth equation. Okay. We have Tn equal to 2Tn by 2 plus Cn. This is the first equation, and the next equation is 4Tn by 4 plus 2Cn This is the second equation, and the third equation is 8Tn by 8 plus 3Cn. Okay. Then if it is like this, what will be our kth equation? What is the relation between this equation number and this values? Okay, we can write it is 2 raised to k, here it is 2 raised to 2, here it is 2 raised to 3, so it is 2 raised to k here, 2 raised to k t, here also 4, we can write it 2 raised to k, this is 2 raised to 2 and this is 2 raised to 3, okay, plus here equation number is 2, here you have 2Cn, here equation number is 3, here you have 3Cn, so it is KCn. Okay, this is the generalized equation. And what will be the equation I, the ith equation? It will be, okay, we are proceeding like this, it will be 2 raised to I T n by 2 raised to I plus ICn. This is the ith equation. Suppose this is the last level, the last equation or the end of recursion. We know the recursion ends when L equal to H, that is only one element. That is problem size equal to 1. The cost will be T of 1. Let it be some secant. That is cost of processing one element. Okay. If I is the last equation, we will be processing the problem of size one element. A function called with only one element, and its cost will be C10. We are assuming that. Then we can say n by 2 raised to I is equal to 1. That is, if ith equation is the last one, then it will become T of n, it is equal to 2 raised to I T of 1 plus ICn. Okay. If this happens, T into n by 2 raised to I is equal to T of 1, n by 2 raised to I is equal to 1, n equal to 2 raised to I, and our I equal to log n to the base 2. Then our T of n is equal to 2 raised to I, it is n. Okay, so n into T of 1, it is, we have assumed it is C10 plus ICn. We know what is I. I is log n, the constant C and n. Okay, we can write the complexity is big O. This is the dominating term, so we can say n log n. We will say the time complexity of this Merz algorithm is big O n log n.